I think we'll sort of go back to something I think you mentioned a little bit earlier, and that's IEC 62304. So that is the golden standard for secure development of a medical device. And it's a pretty lengthy, standard document. It goes into a lot of different information on what you should do for preparation and what documentation you should do, best practices for development, integrating security into your development lifecycle. But one very important thing that it mentions is documentation is going to scale a little bit based on the device's complexity. And complexity can mean two different things. So the first thing we'll talk about is just complexity, meaning is it a small system or is it a big system with a lot of stuff going on? If you have a very big system, tons of different interconnected parts, it doesn't matter if it's a fairly low risk system, there's just going to be a lot more to document by nature of what the system is. And so in that regard, you're probably going to have a lot more documentation for this super complex analysis software that's running in the cloud with a whole bunch of agents deployed on workstations, even if it's just doing an analysis on trying to figure out if you have the common cold or something, compared to a single focus device, like let's say a intubator. That's a much more serious device, much more critical function, but it doesn't really do much. It keeps your airway open. That's all it does. So the documentation on what's going on in that device is likely going to be a little bit more minimal, even though it's a more complex system. Now, inversely, that can also mean the scaling, danger of the device. Something like a pacemaker, an implantable, a class 3 device, is going to require a little bit more documentation and a little bit more scrutiny into what's going on, as opposed to something simple like an oxygen pump, a class 2 device with minimal risk to the patient.